Okay, welcome students. We are going to work back into our construction unit. And you will remember from previous years we've talked about scale diagrams, laying foundations, doing pegging at the perimeter and looking at footings and slab. We've talked about the frame and bracing, and we're particularly going to concentrate on the last three aspects this term, and we're going to look at the roof. So we'll look at the pitch of the roof and roof trusses. We'll look at cladding the roof. So we'll look at different roof types, and we'll look at what we can clad the roof with. And finally, we'll talk about bricking in the walls and to finish off the house. So today we want to look at the roof, and we're going to look at the frame of the roof called the roof truss. And we're going to consider the pitch of the roof as well. So today I want to be able to you to know what a roof truss is, and in the roof truss to be able to identify the king post, the tie beam and the rafter. Then we're going to use that to calculate the pitch ratio from the pitch angle and the king post. So the pitch of the roof is the angle the roof makes with the horizontal. So here's the angle that the roof makes with the horizontal. Now the pitch ratio is written in the form of 1:x. Now x represents the tangent ratio of the pitch angle. So remember, tangent, tan theta equals opposite over adjacent. So this is going to be the opposite, this is going to be the adjacent. So we're not going to worry about the rafter at the moment because that's the hypotenuse. And we'll continue now. So if we have a look at calculating the pitch ratio from the truss below, we want to say, well, here's our pitch of 13 degrees. Here's our king post of 1 meter. So we know that tan theta equals the opposite, which is 1 over x, and the x is what we don't know, so the adjacent. So what is this going to be? So we know that, and we know this here, so that's 13 degrees. So we just need to rearrange. Remember, when you see a fraction like this, these two can swap places. So to rearrange, so we can just say that x equals 1 meter over tan 13. Now that will tell us that x equals 4.33. So that means this is 4.33 meters long. Now we write the pitch ratio as 1:x. So 1:4.33. Now if we have a look here, we've got the adjacent and we've got the opposite, and we want to find the pitch. So we're just going to say opposite over adjacent, and we know therefore we can use tan. So tangent equals the tan of the angle equals the opposite over the adjacent, which is 1 meter over 10 meters. That'll be 0.1, won't it? Now what you're going to need to do is to use your shift button. So we're going to type in shift tan, and that'll come up with an open bracket. Press 1, then your fraction sign, and then press 10. Close your fraction sign and press equals. Now it should come up with 5.71. Now remember to give that answer meaning by putting a degree sign in there, because it's the pitch, and the pitch is the angle the roof makes with the horizontal. We want to calculate the height of the king post. So we've got a building width now of 25 meters. So the extra logical step is to say, what's 25 divided by 2? Well, that's got to be 12.5. And that is in meters. And we want to calculate how high is the king post. Now remember, the sides of the triangle, that's adjacent, that's hypotenuse, and that's opposite. So we're going to use tangent again, and we don't know the opposite this time. So we can write our formula out, and then we can substitute in. We know that tan 15 equals opposite over 12.5. Now we want to make this all by itself on one side of the equal sign. So this time rather than swapping them over, we're going to say 1015 multiplied by 12.5, because remember that's a divided by, and we want to bring that over that side. So the opposite of divide is times 12.5. So to calculate the height of the king post, we're going to say 1015 multiplied by 12.5 meters will be the opposite. And that should equal 3.35 meters. So the king post now is 3.35 meters high. Your work now, folks, is page 276, and that's exercise 7G.